Assalamualaikum and good afternoon to all of you.
Good afternoon, Doctor.
How about others? Are you there?
Waalaikumsalam, Doktor.
Salam doktor.
Nur Atika ada? Nur Atika Syahira?
Saya doktor.
Assalamualaikum.
Salam.
Anis Natasha ada? Okey. Siti Hajar?
Ada.
Okey, kita mulakan semula kelas ya. Okey, Assalamualaikum warahmatullahi wabarakatuh and good afternoon to all of you.
Waalaikumsalam. Good afternoon, sir.
Good afternoon, sir.
Nur Eliza ada?
Ada doktor.
Saya ulang semula ya. Okey. Assalamualaikum warahmatullahi wabarakatuh and good afternoon to all of you.
Good afternoon, sir.
Waalaikumsalam, sir.
Waalaikumsalam, sir.
Fatin Nabilah ada?
Ada, sir.
Nur Aisyah ada?
Ada, sir.
Eka Hairina ada? So, saya ulang semula ya. Okay, Assalamualaikum warahmatullahi wabarakatuh. Dalam kurungan sila jawab. Salam tu wajib dijawab. And good afternoon to all of you.
Waalaikumsalam.
Waalaikumsalam,
Good afternoon,
doktor.
sir.
Waalaikumsalam, sir.
Okay. Ding Ali, are you there?
Yes, doctor.
Good afternoon. Waalaikumsalam. Oh, you're Muslim?
Yes, I'm Muslim.
Okay. So, happy fasting to all of you. So today is the third day. I hope that you guys still able to give your focus to the class. So as for today, we are going to proceed about the number system. Where as for today, we are going to go depth into the arithmetic operation, which is additional and subtraction. Or maybe we are focusing on additional, more on the additional arithmetic process. So before we proceed, okay, can any one of you conclude what have we learned about last 2 weeks? Cuba ceritakan pada saya. Please tell me, what have you learned about past 2 weeks? If there is no conclusion, I can't proceed the content of this course. I need to know what is your understanding towards the content, then I can proceed.
Sir,
Yeah.
last week we learned about conversion of decimal to binary, decimal to octal, decimal to hexadecimal, and then octal to binary, hexadecimal to binary.
Okay. There's some more? Decimal to binary, decimal to octal, decimal to hexa, octal to binary, hexa to binary, and then some more.
So we also learn about fixed point and floating point.
Okay, fixed point and floating point. Okay, all of this answer is a main point of this course. What have you learned about last 2 weeks? So your friend trying to tell you what have you learned and what you need to know. So floating point, fixed point, and then conversion from those system to others. Okay, some more. Okay, let's take one each. One each. Try to tell me only one. One thing that you know, just know, just get the knowledge about it through this course. Just 1 point. There are 21 students here, so I hope that I can get 21 sentence or statement or point according to regarding to what have you learned. What are the things that you freshly you just you get into this course and you learn something new. So what is it?
Sir, can I answer?
Memang kena answer.
Okay. Firstly, yang saya belajar daripada masuk kelas ni, arithmetic number, itu number binary yang sebenarnya tak pernah tahu. So, masuk kelas saya tahu hexal, binary octal dan semua lah.
Okay, terima kasih. Thank you. Okay, yang lain? Ya, Ika. Okay, correct. Lagi apa yang you all dapat daripada what are the things that you get from this course? Lagi?
So we learn about conversion, floating point conversion to binary.
Floating point to binary. Okay, floating point to binary. Remember that using 32 bits number. Okay, some more.
Sir,
Yeah.
conversion from decimal to octal and vice versa.
Okay, decimal to octal and vice versa. Okay, some more. How about the digits according to the systems? How about the digits according to the number system that we use? What can you say about it?
So decimal number ada 10 digits.
Okay, decimal number, we have 10 digits in decimal number. So what are the digits?
0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
Very good. Okay, how about other system, number system? Yang lain boleh jawab?
Octal,
So what are the digits?
0, 1, 2, 3, 4, 5, 6, and 7.
Okay, good. And also we have binary as well as hexa. So okay, basically I can see that most of you understand, get some knowledge about the number system in this course. So Alhamdulillah, thanks God. Okay, so as for today, we will proceed to the arithmetic operation, which is additional and subtraction. But we give more focus to additional operation. So I will show you the. Okay, I will show you the notes. Okay. Okay, arithmetic operation. Okay. So starting from here, we will going to use the binary representation, binary representation as the foundation to do any operation. So for arithmetic operation in binary, there are four operation that you need to memorize, which is okay, the basic one. So 0 plus 0 is 0. 0 plus 1 equal to 1. 1 plus 0 equal to 1. And 1 plus 1 equal to 1. 0 carry forward 1. This is in binary, in binary. So if we convert it into, 0 plus 0. If we convert it into decimal, it will be 0 plus 0 equal to 0. This is in decimal. 0 plus 1 equal to 1. 1 plus 0 equal to 0. And 1 plus 1 equal to 2. This is in decimal. Decimal. So let's say we have one example here. Let's say we have 4 plus 2 equal to 6. This is in decimal. So we want to represent this in binary. So what should we do? What do you think the first step that we need to do? Apa agaknya step pertama yang perlu kita buat untuk wakil? What is the first step that you need to do if you want to represent this calculation or operation in binary format? Apa agak-agaknya? Any answer? Kita nak wakilkan nombor decimal di dalam binary. You want to represent this decimal into binary. So, to your opinion, pada pendapat awak, to your opinion, what is the first step? Nak wakilkan saja dalam binary. The same things, similar things, we just want to convert it into binary.
Convert guna base tu rasa.
Convert, okay, apa dia mula-mula nak kena buat?
Yang guna base table yang tu
Okay, nak convert apa kepada apa?
Decimal to binary.
Yelah, nak convert apa? What is the first step you need to do? Convert? Nak convert apa ni? Ni simple je ni. Kalau saya bagi awak soalan ni dalam decimal, saya nak awak wakilkan dalam binary. Apa yang agak-agaknya, kalau awak nak survive kan? If you want to survive when answering this question, okay, what would you do? What would you do?
Convert 4 to binary.
Convert 4 to binary. This is the first step. Okay, and then second step. Second step.
Convert 2 to binary.
Convert to binary. Okay, and then the third step. So it's the first step. What is the first step? Sorry, the third step. We already know we already get the representation of 4 and 2 in binary. So next,
Add both numbers together.
okay, add both numbers together. Good. This one is correct. Let's say the first step, let's say the things that cross into your mind for the first step is convert 6 to binary. I know some of you will think like this. Convert 6 to binary, the first step. So please change your mind. So please change your mind. This is not the right step lah, because the point here is we want to do the calculation. You need to show the calculation, not only represent the answer in binary, because the question is the operation, the question and the answer is given. The question and answer is given. So your task is to convert the both of the operand here, operand here, and then do the calculation to get the answer. Okay, so this one is correct. Add both numbers together. Don't convert 6 to binary just like that. Okay, if you answer like this for the third step, it means that you know nothing about the operations. Okay, do you got that? Ramai yang fikir macam ni, I know. Some of you will think like this for the third step. You guys, do you get that?
Yes, sir.
Okay. So the first step, what is the process of the first step? What technique that we can use?
Divide 4 by 2.
Divide 4 by 2. So divide 4 by 2. So what will we get? Four divided by two.
2.
Dalam kelas ni tak ada orang ke? Saya bosan cakap seorang-seorang sebenarnya. Okay, 2 and the balance is? The balance is?
0.
0. And then 2 divided by 2. What will we get?
1.
1. Balance?
0.
0. 1 divided by 2.
0.
0. Balance?
1.
So 4 base 10 equal to
100.
100. Okay, and then we got the second step. So what we need to do? So what we need to do?
2 divide 2.
2 divided by 2. The answer is
1.
what is the balance?
0.
0. Okay, 1 divided by 2. The answer is
0.
0. Balance?
1.
1.
1. So 6 base 10 equal to
110.
110. Ni ada banyak lagi ni. Oh sorry, bukan 2, 6. 2 lah kan? 2, sorry, 2. So what is the, sorry, this one is 6. Sorry, 2, okay. So 2 equal to
1 0.
10. Base 2. Don't forget to write the base. If you don't write, if you miss base 2, so it's wrong. 4 base 10 equal to 100, so it's wrong. Because 100 in decimal is 100 and 100. 100, 100 lain dengan 4. It's different. There is a difference between 4 and 100 in decimal. So to make it correct, to make this expression correct, so you need to put base 2 here. So 2 means 4, 2 means binary. So 4 decimal equal to 100 binary. Okay, or 2 decimal equal to 10 in binary. So now the third step, we add both numbers together. So we have 100. Okay, let's say we have 100 and then plus with 10. So we will get, okay, 0 plus 0 is, please refer to this one. 0 plus 0 is
0.
0.
0 plus 1,
1.
and then 1 here, we just
1.
break it down. Okay, 1. So this is the process or the operation, the additional operation in binary representation. Okay. So now we got the representation, and your task is to recheck. Recheck either your representation for the answer is equal to 6. So the fourth step here, you need to recheck either the answer representation in binary is equal to the answer in decimal format. So now we check. 110. 110 is equal to what plus what? We just put bracket here, just show it just next to the answer. So 110 equal to 1. What plus what? What plus what? In binary.
100 plus 110. 110,
1
10.
plus 2.
1 times 2 and the power of. Nak convert pada decimal ni, we want to check. Either the
Up to power of 2.
2 power of 2. Okay, plus
1 times 2 power of 1.
power of 1. plus plus
1 times 2 power of 0.
berapa?
2 power of 0.
Time with what?
2 power of 0. 0. 0 times 2 power of 0.
Okay. It's equal to
4
6.
4 plus
plus 2,
2 plus
0.
0. So equal to
6.
6. So 110 is 6. Is it correct?
Yes.
Okay. So it means your operation is correct. Okay. So do remember the step. Okay, for the first and the second of the step is to get the representation of the operand in decimal to binary, and then do the calculation. Using this formula. Please do not just convert the answer into binary. Please don't do this. This is not the concept. This is just the you just need to if you do this, means that you just memorize the process. I don't want you to just memorize the process. I want you to do the process. So please add both number together using the formula up here. So okay, and then after you get the answer, please recheck. Recheck either the answer representation in binary is equal to the answer in decimal format. So this is the process of rechecking the answer. So if you got 6, so it means your answer is correct. Okay, you got that? Boleh tak?
Boleh.
Boleh, sir.
Okay. I'll give you one more example. You just just copy the similar step. Let's say we have 8 plus 9. 8 plus 9 equal to
17.
17. Mudah je kan? Soalan macam mudah jasad. But the question is like the question in the primary school. So not actually this topic is easy actually. So you just need to know the process, only the process and step. So now okay, and then we have a similar step here, 8, 9, and then okay. First step, what we need to do?
8 divide 2.
8 divided by 2, the answer is
4.
4. The balance is
0.
0. So 4 divided by 2,
2.
balance
0.
2 divided by 2,
1.
balance
0.
So 8 base 10 equal to
1000.
1000 base 2. Don't forget to put base 2 here. Okay, then 9. We have 9 here. So we put more column here, more row. Okay. 9 divided by 2. We will get
4.
4 balance
1.
1. 4 divided by 2,
2.
balance
0.
0. 2 divided by 2,
1.
1. Balance,
0.
0. 1 divided by 2,
0.
0. Balance,
1.
1.
so 9 base 10 equal to
1, 0, 0, 1 base 2.
1, 0, 0, 1 base 2. Okay, good. Now, the third step, okay, we will do the calculation. There's 1, 2, 3, 4, there's 4 bit over there, so we need to add more column here. The right. Okay. So we have 1, 0, 0, 0 plus 1, 0, 0, 1. Oh guys, I forgot to tell you one thing. This is the important part of arithmetic operation. If you do the operation, if you do the operation, make sure the number of bit is similar for both operand. So what does it mean is, okay, for the previous example here, the first operand represented by 3 bits and the second operand represented by 2 bits. So from the view of the principle of the binary arithmetic operation, this one is not correct because the rules is the number the first rule, the main rule is the number of bit must be similar for both operand. So for this operation, you just put 0 here to make it more clear and correct. Okay, just put 0. The point is the number of bit must similar. Ingat tu. The number of bit must similar.
Dia macam kena selaras, Aisa.
Ya. Betul. Remember. Dah letak note dekat sini, so make sure. I just hope that you are not forget about this. Okay. Okay, then we proceed with the second example just now. Okay. Okay, and then saya nak padam dulu. Okay, 0 plus 0 is 0 plus 0 plus 0 plus 1 is yeah, 0 plus 1 Aduh, 0 plus 0?
0.
0.
0 plus 0?
0.
1 plus 1? 1 plus 1?
0 carry 1.
0 carry forward 1 0 0 carry forward 1. So wait. So there's 1 here. Carry forward. And then we just bring the 1 up here to the bottom and make it as the answer lah. Okay, so 0, 1, 0, 0, 0, 1. So let's check first before we do. Oh, first of all, do remember that the number of bit must similar. So what we need to do is to add
0.
0 to both operands. So now we check the answer. 1 times 2 and power of
4.
4. 4 and then this one
0
0
power of 3.
power of 3. And then
0 power
power of
2.
2. 2. And then we put more operation here. And then we have 2 more. Okay. And then
0
times
1. 2
2
power of 1.
power of 1. 1. And then the last one.
1
1 times
times
2
2 power of 0.
power of 0. Good. Bagus. Seronok saya mengajar 88 ni. Okay. Equal to 4 power of 4. 1, 2, 3, 1, 2, 4, 8,
16.
16. Do remember the table 1, 2, 1, 2, 4, 8, 16, 32, 64, 1 to 8. So easy. It make you easy. It helps you to get the answer as faster. So 16
Plus 0,
plus 0
plus 0,
plus 0
plus 0, and plus 1.
plus 1. So the answer is 17. Is it correct? 17?
Yeah, correct.
Okay, correct. So 8 plus 9 is 17. So recheck the question here. So the answer must be 17. So you already checked the representation, and of course it is correct, which 10001 is equal to 17. So this process is correct. If you do like this in examination, you will get full marks. Because your task is just to represent the decimal into binary. That's it. And just follow the step. And again, when you got the answer, please do the calculation. Don't just simply convert the answer to binary. Because you need to check this one. Either the representation you really represent the binary answer. The answer in binary. So this step also brings marks. This step also brings mark in the exam. So that's it for additional operation. Okay, itu saja untuk operational additional operation. Now, what about? Okay, we already learned about the fraction. Okay, fraction, and then what about the negative numbers? Negative numbers. What we need to do if we get the the question in negative numbers. So in binary, in decimal, first in decimal, if we want to represent the negative number, we just use negation like that. Negative. So for positive number, we represent it using the plus symbol. This is for in decimal. So how about binary? Okay, in binary, this symbol is not exist. Plus and minus does not exist. Remember that. So in binary, we will use 0 and 1 to represent positive and negative. 0 for positive and 1 is for negative. Okay, remember this. This is for negative numbers. So let's check the two examples that we have did just now previously. So if you look at here, the first example, 4 plus 2 is equal to 6. If you check the answer here, so 110. Okay, 110. Okay, if we start learning about negative, okay, now we learn about negative, right? So 110 cannot represent, it's not perfectly represent 6. It is not perfectly represent 6. So if you want to represent 6, you need to put 0 in front of the number. So we need to put 0 here. This is the second level. So let's say before this, you think that 110 is equal to 6, but after this, you can't represent 6 or positive number using the things that you already learned or know. Okay, at this stage, at this phase. So what you need to do is to just put 0 in front here. And of course, remember the number of bits must be similar for the operand. So we just put 0 and 0 here. So this is correct. So this is perfectly the perfect answer to represent negative and positive. Okay. So same goes to this one. This one, okay, you see, for the operand, it's correct. 0, the first digit is 0. So 0 means positive 8. So same goes to the second operand, positive 9. But you can see here, for the answer, it is not 17 actually. It is a negative number. So how to correct, how to repair, or how to do correction for this calculation? Nak buat apa agak-agak?
Tambah 0 kat depan.
Tambah 0. We just put 0 to the first digit. Ya Allah. Di bulan puasa ni menguji kesabaran ya. Aduh. Kejap. Macam mana ni tadi ni? Kenapa dia ke bawah? Okay, should be like this. So, kenapa dia macam ni? Oh, patutnya. Apa? Oh, macam ni. To the left. Tidak ke bawah pula. Oh, dah cukup panjang Satu kosong kosong. Kenapa dia ke bawah gitu. Dia ke bawah. Tu je. Confused. Hey. Okay, we just put plus here. And then we just put 0 here. We just put 0 as the first digit for the operand as well as the answer also. Like that. Kenapa kat sini pula ni? Masya Allah. Mana dia? So at this stage, you already learn about the... tolong rakam ya, ada siapa rakam tak video? Ada siapa rakam video tak? Terima kasih. Kenapa jadi macam ni? Okay, dah. Sabar bulan puasa ni, kita kena banyak sabar. Tengok tu. Mana dia tak rapat lah. Dia tak rapat lah. Yes. Dia tak boleh rapat Okay. Cabar So this is the correct representation or operation for the numbers after we learn about negative numbers. So what does it mean here? So actually the things that I want you to know is about the overload. Overload. So example, for this operation 8 plus 9, 8 plus 9, the operation for 8 plus 9 cannot be represented by 4 bits. Because it will be overload. The bit is not enough to represent the real value of the number. Okay, it can't represent the real value of numbers. It same goes to 5 bits. 5 bits. 5 bit also can't represent 8 and 9. 8 and 9 exactly, perfectly. Because why? Because when you do the operation and if you get the answer, so the answer is negative. So the perfect number of bit is 6 to represent the operation of 8 plus 9. Okay. So the overflow. So the overflow problem here could be settled by just add up more bits. Okay. Just add more bits to avoid. What is the problem just now? What is the name of the problem? What is the name of the problem? Just add more bit. Overflow. Okay, overflow. This is the problem. So just add more bit to avoid overflow. Okay, can anybody repeat what is the definition or what is the the condition when if overflow happen? Anybody can tell me? What does it look if the overflow happen in the operation?
If the answer is too big.
If the answer is too big, and then it will represent what? If the answer is too big, it means what? Try to relate it to negative numbers. If you guys can't get what I'm trying to tell you, so let's look at this. Okay, let's say we just only use 5 bits for this operation. For this operation, let's say we just use 5 bits. So the answer is 10001, correct? If you are using 5 bits, isn't it? Betul atau tidak?
Betul.
Okay. So 10001 is not represent 17. It represent negative number. So what is the real value of one? What is the real value of 10001? So to get the real value of the 10001, you can use negation. Use negation to get the real value in decimal. What is the process of negation? So the process of negation is you just, let's say you get the negative numbers, starting with 1 lah, starting with 1. So you just the first step, you need to flip all this. 1 become 0, 0 become 1. Flip. So you will get 0, 1, 1, 1, 0. The first step. And then the second step, add with 1. So we will get 0, 1, 1, 1, 0 plus 1. Plus 1. Okay. This is the step, the step. Add with 1. So the answer is 0, 1, 1, 1, 1. So 0, 1, 1, 1, 1. What's the value of 0, 1, 1, 1 in decimal?
$15.
15. Positive 15, So here, let's say we use 5 bits, without this one. Without this one. So 8 plus, berapa tadi? 8 plus 9 is equal to negative 15. So this one is negative 15, 10001 is negative 15. How do we know that this is negative 15? As I said just now, if the first digit is 1, if you want to know the real or the positive value for this number, you need to do this negation. The first step, flip 0 to 1 and 1 to 0 and then add with 1. And then you do the calculation and then you get the answer. So the answer must be positive lah. So here the answer is positive 15. So what does it mean? It means that 10001 is negative 15. So this one is negative 15. So it's wrong. Okay? 8 plus 9 is not negative 15. 8 plus 9 is 17. So how to correct this operation? As I said just now, this is the problem that arises here is overflow. So if you want to settle down this problem, you just need to what?
Add 0.
Add 0.
Dia macam kalau nak nombor tu positif, kena letak 0 kat depan, Nisa.
Ya, betul. Kalau sebelum ni you all belajar, before this you learn this number brings nothing, tak bawa apa-apa maksud. But now because we have learned about negative numbers, so 0 or 1 as a first digit brings meaning, membawa maksud tertentu. Okay? Alright. So now I already give you 2 example of additional operation together with overflow problem, and then how to solve it and why overflow happens. Why overflow happens, how to solve it, okay? And then what is the connection between the solution to the overflow problem with negative numbers. Negative numbers, okay. At this stage, you have learned this much. So let's say I want you to represent 8 base 10. This is the first question, very simple. 8 base 10 in binary. Sorry, negative 8, negative 8, because we learned about negative already. So negative 8 base 10 in binary. What is the first step? Ni agak-agak je ni, kalau salah tak apa. If you give me the wrong answer is correct. I just want to ask you the random question. So what is the first step?
Convert to binary.
Okay, convert to binary. Very good. Okay, bagus. Convert to binary. Okay, mana tadi? Convert, mana tadi jadual? Dah confused lah. Okay. Okay, convert to binary. Okay, how to convert this one to binary? Macam mana nak convert kepada binary? Okay, nak convert apa?
8 divide by 2.
Sorry?
8 divide by 2.
8 divided by 2. 8 divided by 2. So the answer is
4.
4 balance
2.
4 divided by 2.
2.
2 balance. Kenapa 2 pula? Binary mana boleh 2 dek?
0.
0.
0.
Okay. This one balance
0.
0. And 2 divided by 2.
1.
1.
Balance
0.
0. 1 divided by 2. 0. Balance
1.
1. So 8 base 10 is equal to
01000.
okay, good.
Base 2.
Base
Base
2.
2.
Now you know the function of the first digit, right?
Yeah.
Yeah, I realized that during the first stage, you guys just ignore this one, isn't it? Dekat atas ni, up here, you see, this answer is given by you, you know. You guys tell me the answer. You give me this answer, so you ignore the first 0 here. Same goes to 8 just now. You just ignore. Oh no, this one you put into your consideration lah. But if 0, you just ignore it. This is the first previously, but now I can see that you already put a focus to the first digit. It's very good. That one is very good, very good. Bagus. Your progress is very, very good. Okay, and then, okay, now this one is 8, 8. So how to convert this one to negative? Okay,
Negative 8 base 10 equals to 1002.
pardon? Pardon me? Boleh ulang balik? So what is the option that we have to convert this representation into negative representation? Apa option kita ada? Salah pun tak apa. If you give wrong answer, is also okay, no problem.
Buang 0 dekat depan.
Buang 0 dekat week. Okay, the first answer option that we have, the first option, we just discard the first 0, we cut this one. Okay. What is the next option? The second option that maybe cross into your mind. Apa lagi yang ada? Come on, we have 20 peoples here. I'm sure that there's a lot of answer that cross into your mind. I'm really sure.
Sir, flip the number and then plus 1.
Okay, flip the number and plus 1. Flip the number and plus 1. Some more? Just tell me whatever answer that you think now, because we'll go one by one. Because I want to teach you how to find out logic for the answer that you give to us. There must be a reason why you give that answer, and we need to justify either it is perfectly correct or not. What is the other option that maybe you have? I'm waiting for one more option, because this option is always being selected by the student. The student like to do this, the third option. What is the option? Apa agak option ketiga yang biasa digunakan oleh pelajar? What is the third option that always used by the students?
Sir.
Ha.
Yang saya kata lah, option lah. Is it adding, add one number in front, the first one tu?
Yes. Most of the student will do like this. Ini masa awak kan? Okay.
Tapi saya yang pilih yang pertama lah.
Tak apa. I just want to know the option. Okay. So these are three options that normally given by the students lah. Okay, we go one by one. We go one by one. No problem. At least you know what is the where is the problem for each option. So for the first option, if we just ignore the first 0, okay, now we got 1000. As I mentioned earlier, if the first digit is 1, if we want to check the real value, the positive value of it, we need to do flip and plus 1. Okay, if the first digit is 1, okay, if you want to get the real value, the decimal value for this number, we need to flip and plus 1. Okay, so Hi Muhammad Firdaus and Nur Bacha. Muhammad Firdaus. Okay. So now the first digit here is 1. So if you want to get the real value in decimal, we need to do those process lah. So we flip this one. So we will get 0111. And then we plus the number with, we plus with 1. We plus the number with 1. So we will get this. So we will get 1000. Okay. You see the problem here? Okay, the problem here is, okay, as we assume the first this number is negative because it starts with 1. So we assume with this number is negative. So if we flip and plus 1, the answer that we get is still negative, you see?
Oh, we got answer positive kan?
Okay,
I see.
okay. So what's the okay, betul lah tu. So what's the problem here? Okay, masalah di sini, the problem is the existence of 0. As easy as this, See? Let's say we have 0, 0, 0. Let's say we have 0. Okay, this is the justification, the rational. Why is this happen? Supposedly this one and this one is a pair. Means what? If this number is negative, this one must be positive. It's a pair number. Okay. The rationale behind this is, let's say we want to represent 0 base 10 in binary. Using 4 digit. Let's say 4 digit. What is the representation of 0 base 10 in binary using 4 digit? 0, 0, lagi? Sama?
0, 0.
0. Okay. Okay, this is the representation of 0 in decimal. I just want you to give you the rationale why this option is not perfectly correct. Okay, this one is base 10. Base 2. And then, let's say we find out, we use negation. Flip and plus 1. Flip and plus 1. Is there any answer that we will get? Okay, we will look after this. So let's say we have 0, 0, 0, 0, and then we flip this number. So flip, we will get 1, 1, 1. 1, 1, 1, and then we plus this with 1. So the answer 0 plus 1 is 0
carry 1.
Yeah, carry 1. And then 1 plus 1?
0 carry 1.
0 carry 1. And then 1 plus 1?
0 carry 1.
0 carry 1. 1 plus 1?
0 carry 1.
0 carry 1 and 1 here, isn't it?
Yes.
See? If you do the negation process operation, you will get another answer. Means that from 4 digit or 4 bits, it turns to be 5 digits. So it is not exactly the real digit that we use at the first step here. So means that the couple for 0, 0, 0, the partner for 0, 0, 0 is 1, 0, 0, 0, 0. See? So it means 0 has partners. Is it correct? Is it correct? 0 ada partner tak? In our number system, 0 has partner or not? Partner ni maksudnya negatif positif lah.
No.
No,
but
No. 0 has no partners. Let's say if you say, sir, we learned just now, if we do arithmetic operation, additional especially, the number of bit must similar. Okay, never mind, we just put 0 here. And then the answer is still like this. It still has partners, you see. It still had partners. The point is, here, if we do negation, 0 has partners. That is the problem. The big problem here is 0 had partners. Okay. Now we go to the second option. Okay, because the problem here is 0, 0 had partners. Our problem is 0 had partners. So we check the second option. Either 0 had partners or not. Again, we do this operation 0. Sekejap sekejap. Positif, negatif, positif. Sorry, I think I did mistake over here. Wait a minute, wait a minute. For the first option, okay, this is the rational. Means that, wait. Kenapa jadi macam ni? Sekejap. This is the rational if you want to find out the negative. So the representation of this and this is similar. Okay, this one is for the first option. So there is no partners. There is no partners of 8. Sorry, here the answer shows that 8 base 10 has no partners. No partners, because positive 8 here, this one is positive 8. Positive 8 is 10. Ini baru betul Sorry. This one negative 8. Negative 8. Negative 8 base 10. Okay. Even though in positive we have positive 8 and negative 8, but in binary there is no difference. Okay, no difference. So it means the answer shows that 8 base 10 has no partners. That is the rationale why we trying to avoid the first option. Dapat Okay tak?
Okay.
Okay. Settle. Okay. And then the second rationale, so the second rationale pula. The second option, okay, the rationale is, okay, yang ni kita padam balik We this one, okay, ni padam balik, sorry, this one, this point, you just please forget about this one. Okay, the second option, flip the number and plus one, okay, flip the number and plus one. So here, okay, we know that if we use 4 digits to represent 0, so it will be 1, 1, 1, 1, 1. And if we plus 1, so we will get 1, 0, 0, 0, 0. Okay, the first bit here, okay, you can ignore it. You can ignore it. You can ignore it. Okay. Okay, what is happening here is, okay, the answer shows that 0 base 10 has no partners. This one is correct, Okay. Okay, what does it mean here? Okay, it means that if we do this one, let's say we want to represent 8, positive 8, okay, we just want to change it into decimal or the negative number. So we can use this technique. So, but the problem now is overflow. That is the problem now, overflow. But for others numbers, it will be better. Wait a minute. I think I will give you another numbers. Because 8 is, or maybe we can use 8. Susah sikit lah nombor ni sebab dia border. Okay. What is happening here is, okay, positive 8 here. Sini. That one. Positive 8, Positive 8. So we have 1. Macam tu, Okay. Okay. 0, 0, 1, 1, 1 here. See? If we use the second technique, it has partners. It means there is negative 8 and positive 8. Okay. Okay. Macam tu. Okay. So I repeat, So for the first option, if we just ignore the first digit to represent 8, positive 8, positive 8, what is happening here is, if we do the negation process, or we were trying to find out the couple, the partner for 8, we will get negative 8, 1000. So the representation is similar. So it shows that 8 has no partner, which is wrong, because 8 has partners, positive, negative. So this is the reason why we are not ignore the first bit or first digit in 01000. Okay, let's say we use the second option, flip the number and plus 1. So we flip the number. The number is 01000. Baru betul. Okay, flip this one 8 and then plus 1, so we'll get this. So it shows that there's difference between the first one and the second one. So it means 8 as partners. So this one is correct. Later we will check what is the value of this.
Sir.
Ha.
So that means the first one tu, yang partner tu, the first one tu means represent negative lah kan?
The first one yang mana? First option.
Kan satu, bukan jawapan tadi.
So this one.
The answer bawah. The answer kan 11000, right? So the first one depan tu represent negative lah kan, and then 100 tu 8 macam tu kan?
Yes. Okay. Yes, very correct. Okay, let's check the answer. We check together. Okay, to check this one, either if you want to get the real value of 11000, we use negation. Negation tadi mana? Negation, this one. Sama juga, flip tambah 1. Negation, sama proses dia. So we flip and then we plus 1. So we will get back this. Of course, we will get it back like this. And then plus 1. This one is negation. Negation. Just to check the answer. Just to find out the real value of 11000. Okay. So plus 1. So 1 plus 1 is 0, and then carry forward 1,
Carry forward 1.
and then carry forward 1. 1 plus 1 is
0.
0, carry forward
0 carry forward
1.
1.
Okay, 1 plus 1 is 1 plus 0 is confused. Sekejap, wait.
1.
1 plus 1 is 0, carry forward 1. 1 plus 1 is 0, carry forward 1. 1 plus 1 is 0, carry forward 1. 1 plus 0 is
1.
1. Okay. And then this one we just drag it down here. So, see? We get 8, positive 8, right? Positive 8, so it means 11000 represent negative 8, because if we prove by using negation, it proven that 11000, we find out the positive value of it, we will get this one. So it's proven that 11000 is negative. So for your question just now, so the first one here represent negative. See, this one represent positive. So why this option is correct? Because of this one. This is the rationale, because 0 has no partner, no partners. 0 has no partners. So this is why this technique is correct. The first one is wrong, because there is no difference between negative and positive. Okay. And then for the third option, of course lah, Okay, we know that to get the value or to get the real value in decimal for the number that the first digit is 1, so we need to do negation kan? We do negation. Let's say we do this again. 10100 actually represent what? Represent negative. Jadi berapa agak-agak?
Negatif 4.
Negatif 4. Mari kita cuba. 4 sorry, kosong, satu, kosong, satu Okay. We flip the number first and then we add this one. Okay, betul tak negatif 4?
Sir,
Ya.
memang ada lagi satu kosong tu dekat belakang.
Ada lagi satu kosong dekat belakang. Yang mana yang ni?
Yang 1010000. Kosong ada 3.
Oh, ada 3 Oh, kosong ada 3. Okay. Kenapa jadi banyak nombor ni? 10
Buat tambah 1 kat depan.
Allah. 10 100. Betul lah macam ni kan?
Tak, tadi yang asal kan ada 5 digit. So yang third option tu kan kita tambah 1 kat depan, so jadi 6 digit.
Oh, so salah lah kat sini. Sini macam ni kan?
Ya, betul.
Maaf ya, 100,000.
So jadi negatif 8 lah.
Negatif 8 ya. Okay, let's check together. So kita ada 1 dekat sini. Kita tambah 1. Okay. So 1 tambah 1, 1 plus 1 is 0. Carry forward 1. 1 plus 1 is 0. Carry forward 1. 1 plus 1 is 0. Carry forward 1. So we have 1 here. And then we have 1 here. And 0 here. Berapa nilai sebenar dia? What's the real value of this representation?
25.
25 1, 8, 1, 2, 4, 8 campur 16.
24.
24.
Positif 24.
24. Is 10, see? So here, if we choose the third option, okay, we just add 1 and 0. So it means, you see, you change the value from, this one actually represent positive 24. It is not represent positive 8. So 101000 base 2 actually represent positive 24 base 10. Not positive 8. Positive 8 base 10. So this is why we use the flip plus 1 second two's complement. Nama dia two's complement. Okay, this one using two's complement. Ni nama dia two's complement. Saya lupa pula saya. Using two's complement. So flip the number plus 1. The process of second complement and negation is similar. Sama je proses dia. The process of negation and second complement is similar. So this is the process of second complement or two's complement. Two's complement. Sorry, two's complement. But to get the real value, the real value of the number that start with 1, so we need to use negation. Use just to find being used just to find out the real value of 11000. So this is the technique of negation. It's actually similar. Negation and two's complement is similar technique. Only the name is different based on the purpose. Okay. So this is the rational. For the third option, this one, it not represent correctly the positive numbers. Okay. So it should represent negative 24. Not positive 8. So I already give you the rationale for each of the option. Okay, that's it. Is there any question? So today you have learned about overflow and then about negative numbers, how to find out the negative numbers from the numbers is given, from the positive numbers given, and then how to find out the value or the real value of binary number that start with 1, which we need to use negation. Gitu. Okay. So anything that you want to ask me? I'm trying to finish up the class at 4 o'clock. So we have 15 minutes more. You can ask me question if you don't clear which part that you are not clear.
Sekiranya second option lah yang betul kan?
Yes, the second option is correct. So what is the second option? The second option is if we want to represent a positive number in negative, we need to use second complement, which is flip the number and plus with 1. And if we are given the binary number starting with 1 like this, we need to use negation to find out the real value of the representation. Okay, any other question?
Sir,
Yeah.
negation tu untuk number yang starting daripada 1. Kalau two's complement tu yang start daripada number 0 lah.
But yang negation tadi betul. Your definition of negation is correct. But for second two's complement, we use two's complement to find out the negative representation of positive numbers.
Okay, faham.
Okay, use two's complement to find out the negative representation of positive number, because starting from the first week, we just learned about how to represent positive number as usual, as what you understand before this. You just use it, but for negative, we just need to flip it and plus 1. That's it. That one is two's complement. But if you see the the binary digit starting with 1, bit 1, so to get the real value, you need to do negation. The process is still similar. Okay, I give you one question, so please find out the answer for this question. Let's say we have two minus 3. 2 minus 3. 2 minus 3. So we know the answer is, by assumption, the answer is what? 2 minus 3?
-1.
-1. So this is our assumption. By assumption that the answer is, okay. So what is the first step to do this calculation in binary? Buat apa?
Convert to binary.
Convert apa to binary?
To
2 binary. So let's do it together. Okay, we just insert table. Okay. Lah. Okay, 2 divided by
2.
the answer is
1.
1.
balance
0.
0. 1 divided by 2,
0.
0 balance.
1.
So 2 base 10 is equal to
0 and 0 base 2.
Good. So please take into account 0 here. Okay. Don't just do not ignore the first 0. Can get 2. And then the second one okay, the second step.
Convert 3
Convert 3.
to binary.
Kalau convert 3,
Mana boleh?
korang kena buat tolak. Saya tak ajar tolak.
Convert -3.
Convert negative 3 to negative. Jangan pakai yang tu ya. Saya tulis jawapan awak sebab nanti kita boleh refer. Nanti awak boleh tahulah reflection. Convert -3 to binary. This one is correct. Okay, tak apa. Okay, now apa step? What is the step to convert 3 to binary?
Saya tulis benda yang sama.
Ya ke? Apa saya tulis ni? Ya Allah. Convert 3 to binary kan? Okay. It's the first step to convert -3 to binary. Mula-mula nak buat apa? Tadi kita dah buat ni. What is the first step to convert 3 base 10 to binary?
-3 divide 2.
-3 divide by 2. Kita tak pernah belajar pun bahagian dia negatif. Daripada awal tadi kan, tak pernah pun. Okay, nak buat apa?
3 divided by 2.
3 divide by 2. Baru betul. 3 bagi 2 adalah 3 divide by 2 is 1. Balance?
1.
Balance is 1. Okay, 1 divide by 2. Balance 0. Balance 1. So, we find out 3 first. Kita dapat 3 dulu. Sekejap. 10. Okay, 3 base 10. 3 base 10 is equal to 0,
011
1, 1 base
base
2.
2.
And then what's the next step?
Just complement.
Change to first ke second complement? Kalau first complement kita flip je. Use first complement or second complement? One complement or two complements?
Use 2's complement.
Two's complement. Two's complement. Two's complement ni is the combination of first complement plus 1 which is first complement plus 1. So it's equal to first complement is we flip the number flip the number plus 1. So it's equal to what is what's the flip number?
100.
100 plus 1. Okay, and then what do we get? 1,
101.
101. So this is negative 3. Base 10. Okay, now we already got the operand 2 and negative 3. So what's next? What is the third step? Operand dah settle dah ni. You already get the operand in binary. So the third step is apa? Ini soalan awal tadi. This is our question, our objective. So we already got this one. And we already got this one. So what's next?
Tolak.
Tolak. Kalau tolak dapat 2 tolak negatif 3 kan? Kita nak kalau buat tolak, tadi ada kata tolak kan? 2 tolak negatif 3.
Tambah.
Dah jadi tambah. Assumption kita tadi apa? The answer is negative 1. Suddenly this one we got 5. So betul ke salah?
Salah. 2 plus negative 3.
Salah. So kita potong 2 plus
Negative 3.
2 plus negative 3. So 2 plus negative 3 equal to 2 equal to in binary we got 0 1 0 plus negative 3. What is the representation of negative 3?
101.
0 1 101 Okay. Now we do the additional process operation. So we will get what?
111.
111. Answer is 111. So this question is this represent berapa tadi jawapan tadi? Negative 1? Is it really represent negative 1? This 10. Dia tak tahu ni. We don't know either this answer is correct or wrong. So what should we do? Use what?
Negation.
Use negation. Baguslah awak ni. Use negation. So, what is the step? 1, 1, 1.
0, 0, 0.
0, 0, 0. Tu je.
Plus 1.
Plus
Plus 1. Kita akan dapat what will we get? Alamak. Okay, dapat apa?
0, 0, 1.
0, 0, 1. So 0, 0, 1 is? What is 0, 0, 1? In decimal?
Positive 1.
Positive 1. So what does it mean? What does it mean? It means that Ya Allah. It it means that 111 base 2 is equal to
Negative 3. Negative 1, ya Allah.
2 minus 3 negative 3
No, negative 1, sorry.
Negative 1. Okay, that's it. So this is the answer that we want. Actually, this is the answer that we want. So for this part is only to recheck, use recheck the answer using negation. Nampak? So this is the answer that we want actually, this one. Okay. So any questions? Any questions? Soalan? Tak ada soalan? Betul tak ada soalan? Are you sure that you have no question to ask me?
Sir, saya keliru.
Ya.
Kan kalau dalam base binary, base tu, 111 tu macam 7 kan?
111 bukan 7. 7 is 0111.
Okay.
0111 is 7. 111 bukan 7. 111 kita kena buat negation baru tahu nilai dia berapa.
Oh, okay, faham.
Macam ni kan, 111 kita buat negation, then here we got 1, positive 1, so it means this one is the couple for this one. So couple partner lah negative positive. So this mean negative 1. Okay, some more?
So kalau 111 tu boleh jadi negative 3 ke?
Negative 3. Okay, negative macam mana nak dapatkan how to get the negative representation? Kita dah 2 kali buat tadi kan, bagaimana nak dapat nilai negatif? Apa step yang pertama? The first step to get the negative number for the positive number. Ya, apa soalan awak tadi? Apa soalan? What is the question just now?
Entah 111 tu boleh jadi negative 3 ke?
111 negative 3, okay, kita tak tahu nilai dia berapa. We don't know what is the value of 111. Me also, I don't know the value of it. I need to do negation. Okay. So if we want to find out the value, the positive value of 111, we use negation lah. So we'll get positive 1. Let's say tadi kata nak wakilkan negatif 3 kan? So what is the value of negative 3? Okay, starting with 3. Kita dah buat 2 kali tadi how to convert this one, negative, this one, question, this question, how to, this one, how to get negative 8. See what is the step here? This is the first step. And then the second step, we do this. See? There's a 2 step here. So, what is the step to get negative 3? How to get negative 3? What's the first step?
Tadi bagi 2.
Bagi 2 apa? Negatif 3 bagi 2 ke?
3 bagi 2.
3 bahagi 2. First step, divide positive 3 with
2.
by 2. And then after that, next step,
Terus complement.
two's complement. Do two's complement. Itu je. And then recheck lah. And then the step recheck answer. Don't forget to recheck. Kena selalu recheck answer. Tak tahu nilai dia betul ke tidak. We don't know the answer is correct or wrong. We need to recheck using second complement. So 3 divided by 2 kita dapat berapa? 3 divided by 2 kita akan dapat 0
011.
011. Betul lah tu. 011. And then do the second complement.
0
0 0
100 plus
plus 1.
plus 1. Kita akan dapat
101.
101. So 101 is representation. What?
negative 3.
Negative 3. So soalan tadi negative 3 kan? So 111 is not negative 3. Negative 3 is 103. What's 103? 101. This is negative 3. Okay? Okay tak?
Faham. Tadi saya kan boleh baca macam tu. Macam yang tadi 8 tadi tu boleh terus jadi dapat negative 8.
8 tak boleh terus dapat negative 8. Kalau 8 terus dapat negative 8, salah. Macam ni kan salah tadi. Kalau 8 ni tadi terus dapat negative 8 macam ni kan. Kita ignore ni. 8 ni. Nampak ni salah. Kalau letak kosong dekat depan 8 ni, kita kena still lagi buat ni. Baru dapat macam ni. Okay, yang ini, yang kan awak kata terus dapat negative 8 by just put 0, 1 in front here, right? Actually, the process is not just put one here. The process is not just put just like that. No. The process is first complement plus one. Then we get this one.
Maksud saya baca tu yang 110 yang kita dah dapat tu boleh baca terus dapat negative 8.
Oh, tak boleh. Bukan. So ini, if you want to check either this one is negative 8 or not, we need to use negation, see? We just not simply assume it as negative 8, kan?
Betul.
Kena buat juga negation ni. Baru kita boleh buktikan. Then after we do negation, then we can prove that this one is positive 8. Really, this course is for a proof. You need to prove your technique is correct or wrong. That's it. This course is very simple actually. We just represent the number using binary and then prove your answer. I already give you the technique how to find out the answer using formula such as floating point using n formula to check your answer in decimal, and then you can change it into binary. See, so each of the things that we learn in this course, there's a technique to recheck your answer, either it is correct or wrong. So don't forget that the number that we have learned in this course is not only decimal and binary. So maybe the question is given in octal format or hexadecimal format. Sometimes you need to do the additional operation using binary, but the question in hexadecimal. Sometimes you need to do the calculation in hexadecimal, kan? But the question you need to do the calculation in hexadecimal, but the question is in binary. Macam tu. There's so many questions that you can see in this part of this course. This one is just for the foundation. I show you the decimal and the binary. How to represent negative, how to represent positive, how to represent floating point number, and that's it. The type of numbers. So fraction, and then fraction is floating point and fixed point lah. And then we have negative and we have positive. Only 3 types of number using 4 type of number system. So as a conclusion for this part of this course, it's already finished. Only this part. So for this part of this course, until this part, so you have learned about 4 number system, which is octal, hexadecimal, binary, and decimal. And you also have learned about how to convert from one system to another by using certain technique. And then you have also learned about the floating point and fixed point number, how to present the fixed point and how to represent floating point. And then you have also learned about the negative numbers. Okay, and all of that numbers will be used in the arithmetic operation, where when you want to execute the arithmetic operation, especially additional operation, you need to do step-by-step process together with verification, which is two's complement for the negative numbers, and recheck your answer. If the answer is negative, which is starting from 1, you need to recheck your answer by using negation. So actually what we have learned about from last week, from the first week, from the beginning until last week, actually is the preparation of doing arithmetic operation. Itu sebenarnya. That is the real thing. The thing that you learn from the first week to the second week actually is the preparation to do the arithmetic operation, which is additional operation. Itu je. That's it. So now your point actually is to do the arithmetic operation, which is addition. So your knowledge before this, you conclude it and you use it in the additional or subtraction operation. So settle. this part. So any question? So normally after finish this part, I will execute the quiz one. Quiz one normally. And if there is no quiz one, I will execute midterm exam. But we need to learn more about logic. This one is arithmetic. After this is about logic. So both arithmetic and logic will be combined and will be asked through middle semester examination. I give you chance to choose either you want to do quiz or midterm exam. If you do midterm exam, only one shot exam. But if we do quiz, there are two quizzes. The first one is this for this part this part which is arithmetic operation, and one more part. The second quiz is on logic operation. So I give it to you to make a decision. If you want to do quiz, so the first quiz will be done next week. If you choose quiz, so the first quiz will be executed next week, which contains this topic, which is arithmetic operation. If you choose middle term exam, so we need to wait after the logic operation after finish logic operation. Okay, boleh? Any question?
Kena undi ke macam mana sah?
Sekejap ya, wait. Bila banyak bercakap ni, air liur terkeluar kan batal puasa saya. Okay, what is the question just now?
So kena buat undian ke macam mana ni?
Discuss lah. Discuss among of you. Dalam group ke mana-mana you say discuss, you nak quiz ke nak midterm. Kalau nak buat quiz, minggu depan dah ada quiz lah. If you want quiz, next week we have quiz lah. If you don't want quiz, so we wait until maybe after Raya, because we need to learn about logic about 1 or 2 weeks about logic about logic, which is chapter 3 already. Chapter 3 So this one is chapter 2 Chapter 1 you just read on your own pace. That one is not so important actually. The first chapter. This one is important, the second chapter. And then for the second chapter, the notes is this one. Do not refer to the slide that I upload to my guru because that slide is quite technical. Technical, and it has no part about hexa and octal. So use this note for the second chapter. For the third chapter, you can refer to the slide. We will use slide for the third chapter.
Sir,
Yeah.
kalau we choose for quiz 1, nanti untuk midterm ada tajuk ni juga ke?
Tak ada dah.
Okay. Kalau quiz 1 ada berapa soalan?
Sometimes I prepare about 10 questions. It's up to the type of question that I will ask you. Sometimes there is only 2 questions, big major questions. Scenario. The scenario kan, and then you just answer the question based on the scenario. One big question. Sometimes there is a very small question, such as how to convert hexa to octal, how to convert octal to hexa, or how to convert this to this, that to that, how to get the floating point for this number, how to get fixed point for this number, how to do this, or only that. All the simple question. But if the question is only one or two major question, normally the question is quite big. Maybe it's involve a scenario where you need to do the arithmetic operation. I mean, you find out all the component, all the operands, all just like what we did just now, but only in the form of scenario. Means that you need to prepare the operand, you need to prepare the operand if the operand is negative, you need to prepare the operand if the operand is floating point, you need to ready the operand if the operand is in fixed point. That one is if the question is is less, but the size is big. Maksudnya it means that maybe one or two question, major question, but the content that in that question is quite, you need to prepare all of those things that I've told you just now. Itu beza dia kalau soalan besar dan soalan kecil. If the question is just a small question, like I said, just convert the one system to another just to find out the representation for the numbers. Boleh tak?
Okay, sir. But the duration for answer the quiz one, berapa lama?
Only 1 hour.
But I think kena buat lagi macam untuk fixed point hari tu kan sir ajar macam dah nak habis kelas kan. So maybe kena buat lagi exercise kot.
Fixed point.
Fixed
point. Nanti
fixed point or floating. I think fixed point.
Boleh, tak ada masalah tengok ni Sekejap je sebenarnya tu, kejap. Okay, fixed point Fixed point, okay, actually fixed point and floating point ni the same number. Same number. The difference is in the question itself. Either the question asks you to find the representation of fixed point. It's already stated in the question, fixed point. Or maybe the question asks you to find out the representation in IEEE 784. This one is floating point. The question asks you to find out the representation in this format. You see here, this one is 5.25. The example here is similar like this one, 5.25. So means that the number is similar. The technique is different. So for fixed point, the first step, find out the number after point here, divide by 2 as usual, and then for the number after point, we need to use this technique, times by 2. Times by 2, like 0.25 times 2, 0.5. And then the red one becomes balanced. And 5 here, we bring it here. This is for the example lah. And then here 0, we bring it here. We bring it here. And then we combine the first one here and here. So we got this one. So this is the floor fixed point number. But do remember, don't forget to put 0. Because we have learned about negative just now. So don't forget to put 0. This one is positive 5.25. So for plotting, you just want to check the answer. This is just you want to check 010. Just do like the similar step. The same things. We do the same things again and again and again. Except for this one. This one is a new thing. So you need 2 times with 2 and negative 1. 2 and power of negative 2. Because this floating point, right? So we need another calculation lah for the number before point. So I already give you the table up here. Mana table tu? The table for point handy. This one, 0.5, 0.25, 125. So this is the value of the number before point. This one is the value after point. Itu floating point. Kemudian, then we get back the answer. See? Letaklah kosong kat sini. We put 0 here. And then 0 times 2 and the power of 3. So we have learned about negative, right? So we need to repair this ni lah. See? So we have 0 plus macam tu. 0. This one is for fixed point. For floating point, the similar technique, find out the 5, the representation of 5, and then we got this. And the same technique too, same like floating point just now, we used times with 2, and then we combine both of these, then we get this one. Okay, put 0 here. But we just extend the technique by just carry forward the point. We just bring the point to the front until it find the first one here. So for this example, the red point here, we just carry 1, 2 step here from red to orange. So from red to orange, it will become 1.0101 times 2 and the power of 2. So 2 here means base 2. The 2 yellow here means power of 2 represent the number of movement. See, the big 2 represent base 2 number. So this one is represent base 2. This one is how many movement that you make to bring the point here to the front. See, so this is the example. Let's say kalau we have this number, another example here. If you have this one 11100.111, we just bring point here to the front here. Bring it here. We bring it here. So it become 1.1100111. See how many steps that we bring the point to the front? So 1, 2, 3, 4. So 2 and power of 4. Sekejap, nanti confuse pula sekejap See? So just bring the point to the front forward. Bring it forward. And then it will become like this. Times by 2 and power of 4. 2 means base 2. 4 means how many movement that you make. So and then use this formula. This formula is especially for exponent. Exponent minus 1 to 7 is a formula. Equal to the number of movement. We know here that we move 2 times. So equal by 2. Equal to 2. Equal to 2. So exponent equal to 2 plus 1 to 7. So we got 1 to 9. So we change 1 to 9 into binary. We got this. 1 to 8 plus 1. So we got 1 to 9. 1 times 2 and power of 0 plus 1 times 2 and power of 8. We got 1 to 9. So this is the value of fraction. Value of fraction. And then we find out the sign for the number. We know that the question is in positive. See, positive 5. So positive means as sign. Sign is 0. 0 means positive. So just use 0 for S. If the number is negative, just use 1. That's it. As easy as that. It's very simple. And then fraction is this part, the blue part here. Means the part after we move the point forward. Okay, after we move the point forward, so the blue part here. Kejap, kenapa dia macam ni? Sekarang confused sekarang. Okay. Okay. So the blue part here, we just take this part and put it here. And then we add more to 23 bits. 0 bit. Just to make sure the overall number is 23. As easy as that. Here we already have 4 here. 4. So 4 plus 19 here. So we got 23. This is the formula. We need to find out 23 bits for fraction. And this one is 9 bit. This one is 1 bit. So settle. And then we combine sign, fraction, and exponent. Sorry, sign, exponent, and fraction. We combine everything here. This is for sign. This one is for exponent. We got it from here just now. And then fraction. So overall, The answer is in 32 bits. That's it. And then to get back and to find out or to check the answer, because it's so quite long, we don't know either the number, what is the value of the number in decimal. So we need to use this formula. So please choose the correct formula based on the value of exponent. Here we have 1 to 9. So 1 to 9 is the first formula. This one is for 1 to 9. This one is for exponent equal to 0. Other than that, using this one. So we just copy the formula and then just replace S with 0. 0 mean, because we got 0 here, S. So put 0 here. And then for the fraction, we know the fraction is this one. For the fraction, remember, fraction is the number after point. So this one is 0.5. This one is 0.25. Please refer to this table. This table. That's why I ask you to remember this one. And this one also, please memorize this one. If you memorize this, it make you more easy for you to understand. Okay, this is number before the point form. This one is, sorry, this one after point. This one is before point, 0.5, 0.25, blah, 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 blah. And then, what is that, floating point? This one. Okay, so this one is 1.25 plus 1 point, berapa tadi? 1.0625, which is this one and this one. Kan kita kena, this is the technique how to get the decimal value, right? We times with 2 and power of something. Maybe you confused because the number is after before point. So you confused. Normally you just time with 2 and power of 1, 2 and power of 2, 2 and power of 3, 4, 5, kan? 1, 2, 4, 6, 1, 2, 4, 8, 16, 32. So you familiar with that sequence, but you are not familiar with 0.5, 0.25, 0. Apa nama tadi? 0.125, 0.0. This one is not familiar. That's why I ask you to remember the number before point. Please use this sequence. So that's why we got this one. Method floating point. Floating point, floating point. Okay, this one. Ah, 0.625 times 2 and power of exponent is this one. So 128 plus 1 is 2.129. That's why I ask you to remember 1, 2, 4, 8, 16, 32, 64, 128. If you remember the sequence, you directly you can add 129 plus 1. As easy as that. So minus 127 is in the formula, see? So, and any numbers that power with 0 is 1. So times 1 dot this one plus this one. So we got 3125. And then answer and just do the calculation and then you get back the 5.25 here. Get back the question here. See? So what does it? It means, okay, let's say you are given this number. Okay. Try to find out the decimal representation of this number. Do it now, Formula tadi. Okay. Okay, I already give you this note. So by referring to the note, please get the representation, the value, the decimal value of this one. Find out the decimal. Okay, first of all, find out the hexadecimal representation. Find out the hexa value of the question. And then the second one, find out the decimal value. Decimal value for the question by using formula N. Cuba buat. Now, sepatutnya soalan ni boleh jawab within, you can answer this question within 5 to 10 minutes. Tak lama pun. Please answer this question within 5 to 10 minutes. Now. Untuk soalan pertama, for the first question, you should answer this within 3 to 5 minutes. It's very easy. Okay, 2 minutes left. Okay, so what is the first answer? What is the answer for the first question? Sebelum tu, before that, what is the technique that you can use? Teknik yang penting, teknik. The important part is technique also. What is technique that you can use? Cepat dek, senang ni. Teknik apa ni? Binary kepada hexsa guna teknik apa? Guys, dah habis 3 minit. Binary kepada hexsa guna teknik apa? What is the technique used to convert binary to hexa? Cepat.
For binary digit to one digit hexa.
Apa dia?
For binary to one hexa.
So what is the answer? Teknik dah belajar kan? Jangan takut, teknik dah belajar. So what is the answer? Ni 3 minit dah boleh selesai ni. Banyak kosong. So many zeros so that you can get the answer within 3 minutes actually. Come on guys. One more thing in floating point, if the first number is 1, if you want to get the real value in decimal, do not flip and plus 1. This is only for floating point, because floating point we just change this one 0 to 1 and 1 to 0. That's it, to represent negative or positive. So please do not do flip and plus 1. So what is what is the answer for the first question? Guys, come on lah. What is the technique? What is the technique just now? Korang tak nak jawab ke soalan saya ni? Sekarang saya diam sampai hujung semester sekarang.
Jangan tu.
Saya diam sampai hujung semester. Masak kamu nanti. Teknik dah tahu tadi kan? Come on, have 22 people here. 22 people. Cepatlah. Annoying kan saya ni kan? I'm quite annoying. Actually, because the first question is very easy. That's why I force you to get the answer as soon as possible. Seorang pun tak dapat jawab ke? Ke takut nak jawab? Takut salah? Guys, cepatlah, dekat pukul 5 dah ni. Okay, what is the technique for the first question?
One digit hexa equal 4 binary digit.
Itu teknik dia. That is the technique. So, how to do it? How to execute the technique?
Bagikan 4 digit dulu.
Siapa yang jawab tu?
Nurul Aisyah.
Dia awak seorang dalam kelas ni. Yang lain bagaimana, tidur ke? Nur Ali ada?
Ada.
Ada. Awak tolong mak, cepat pukul 5 dah, mak panggil kat dapur nanti. Tolong mak masak, cepat. Cepat bahagi 4 macam mana? Cepat selesaikan. Ni mak panggil kat dapur tu nak masak.
8, 1, C.
Pandai. Berapa? 8?
1, C.
1 C. Pandai. Yang lain-lain kenapa diam? Dapat tak jawapan? Tanya pun tak. Dapat jawapan tak?
Dapat.
Lagi yang lain 2 orang je. What about others? Do you get the answer?
Dapat, sir.
3 orang. Sama? Kalau 3 orang je yang bercakap kan, saya nak buat kelas untuk 3 orang je.
Dapat, sir.
Betul. Kalau tak nak bercakap, saya buat kelas untuk yang bercakap je. To those who are not speak in this class, I won't talk to you. I will do another group. Macam mana sekarang? How about others?
Dapat, sir.
5 orang. Yang lain?
Dapat, sir.
8, sir.
9. Only 9 students got the answer. How about others?
Dapat, sir.
InsyaAllah dapat. Okay, yang lain 10 orang. Ada 12 orang. 11 orang lagi. There are 11 students in this class. Where are you guys?
Dapat, sir.
Lagi. Cubalah bercakap lagi.
Dapat, sir.
Lagi 9 orang. Where is another 9 students?
Dapat, sir.
Dapat, sir.
Dapat, sir.
1,
Dapat, sir.
6, 5. Ding Ali.
Yes, Dr.
Do you got the answer? Do you get the answer?
Yeah, I try to calculate.
Try to calculate. You still don't get the answer?
Yeah, maybe get a little problem.
Jenuh lah. Okay, lagi sama. How about others? Zuzuan, siapa ke nama ni? Kejap. Ada 2 orang lagi international student dah repeat paper ni for so many times. Okay, never mind. So divide by 4 by 4 one digit equal to 4 bit. Overall total is 32. Okay, let's say okay, first of all, okay, you need to do like this, right? 4 by 4. Let's say macam ni that's the way how we do it. Okay, as easy as that. So for the second one, which formula that we can use? The first, the second, or the third one? You have this note, right? So which formula that we can use? Primila. Premila. Premila? Mana pergi? Tengok ni dia tak ada. Premila? Korang ni kenapa lah hilang? Premila, are you there? Nanti tak dapat jawab. Siapa nak belajar ni? Awak ke saya? Premila, are you there? Tak ada. Yang lain siapa? Mana nak tengok nama banyak-banyak ni? Dah tengok nama ni. Cuma tengok. Gaji. Jun Zian Lee.
Yeah, teacher.
What is the formula that we can use for this question? Which formula? Thickness? Thickness? Yeah, Juzali, what is the formula?
Yeah, I'm looking this.
Okay. Thickness? Where is thickness? It's okay, Junjian Lee. It's okay. Thickness. What's the formula that we can use for this question? Tak ada ni. Thickness. Ni dua-dua orang ni tak ada pergi mana ni Korang kalau tak nak belajar paper ni, tak payahlah ambil paper ni, boleh tak? Please don't register for this paper if you guys don't want to learn about it. You're just wasting your time and wasting my time too. Panggil nama pun tak ada. Macam mana? Sekarang bulan apa-apa saya buat exam, kan dah menyusahkan diri sendiri. I can buat exam I can avoid you from taking the exam, Siapa nak jawab? Formula mana boleh guna untuk soalan ni? Sign dah tahu dekat mana, exponent that you know the position of sign, you know the position of exponent, you know the position of fraction, and then you know to select the formula you need to find out the exponent value. So which formula that we can use? The first one, the second one, or third one? Guys, what is the fraction? What is the exponent of this number in binary? Tak nak jawab je.
Yang first fraction tu sir.
Ha? Sekarang ni, okay, we have three formula here. How to decide which formula that we can use? We need to look at the
First number.
What?
look at what? If we want to select which formula that we can use, which one, so what do we do?
Cari exponen.
Cari exponent dulu, find out the exponent. Because the first formula, this is the rules to use the first formula, kan dah ada kat tepi ni. You all ni tak reti tengok formula mathematics ke? This one is for exponent 0. If from 0, you use this formula. Exponent other than above, use this formula. So now in this question, what is the value of exponent? Step by step saya jawab, one by one, memang suap habis ni. So what is the value of this exponent? What's the exponent of this number? Yang mana exponent dia? Yang mana panjang-panjang ni? In this answer, which one is the exponent? Bit nombor berapa? Which one is the exponent? Ya Allah, macam ada.
Sir.
Ha?
100001.
Exponent?
129.
129? Bit 1 ke? Exponent start bit nombor berapa?
Number 2.
Number 2.
Yeah.
Number 2. Nak menangis saya ajar. Okay, number 2 sampai until?
Number 9.
Ada berapa ni semua ni?
8.
Ini exponent. This is exponent. Kan dah cakap dekat atas ni. Ya Allah. Ni. Tengok aku ulang boleh ni atas. Tengok ni. Ni exponent kelabu ni exponent. Ni exponent. This one is exponent guys. This one is fraction. This one is sign. Viknis, are you there? Seronok dia orang tak dalam kelas ni. Aku yang puasa ni pula buat kelas. Ni boleh menyebabkan kemarahan ni. Sekarang aku tak nak buat kelas sekarang ni. Siapa ni seorang lagi? Tadi Primila tadi tak ada dah. Muhammad Firdaus, are you there? Tengok dia orang tak ada. Saya ambil nama Saya ambil nama, saya nak buat grup lain lah. Daripada saya bercakap dan membazir masa, penat nak bercakap, lebih baik saya mengajar orang yang nak dengar. I want to get an attendance Anyone who answer me, I will make another group for you guys. I want to separate you with the one who are very quiet, silent and say nothing in this class because you guys make me demotivated, you know. Siapa yang tak bercakap ni menyebabkan saya demotivated. Saya tak naklah demotivated, saya nak positif. So saya nak buang semua yang negatif dalam hidup saya, termasuklah student yang negatif tak nak bercakap langsung itulah orang suruh bercakap tak nak cakap. Saya tak tanya soalan susah kan, saya cuma tanya apa masalah awak. Tu je teknik bagaimana nak guna kan. Tu je. Aku nak ambil nama. Saya buat grup lain siapa yang korang ni saja je menyusahkan. Saya dah baik-baik dah ni. Okay, Anis, are you there?
Yes.
Ding Ali, are you there?
Yes, doctor.
Ya, ada. Eka Hairina? Hao Guan?
Yes, sir.
Fatin Nabila?
Ada sir.
Goji?
Yes, doctor.
Jun Zian Lee?
Yes, doctor.
Muhammad Firdaus? Muhammad Hafizuddin?
Ya, doktor.
Ada pun yang ada lakinya. Aku ingat semua budak perempuan dalam ni tahu. Hasni Nadira.
Ada, sir.
Okay, Nurliza.
Ada, sir.
Nur Atika.
Ada, sir.
Nur Azrina.
Ada, sir.
Nur Alia.
Ada, sir.
Nur Iliana.
Ada, sir.
Nurul Aisyah.
Saya.
Siti Hajar. Siti Hajar.
Saya, sir.
Viknes. Zhang Kaizing.
Hello, doctor.
Siapa tu?
Yes, sir.
Viknes, where are you going just now?
I'm at toilet just now.
Berapa lama awak ke toilet?
I came back.
I asked you 2 times, 2 or 3 times. So please stay in this class. If you want to go anywhere, so please let me know.
Sure, doctor. Sorry, doctor.
To those who want to go to toilet or everywhere, so please let me know. Don't just left me like this. Jangan tinggalkan saya macam ni. It's similar like people, when you talk to other people and then that people just go like that and just leave you alone. I feel like that. Saya rasa macam tu sebab kita tak nampak. Okay, we are online class, so I can't see you. If you want to stop, just let me know. I will stop this lecture, that's it. Because my plan today, I just want to make class until 4 o'clock. Itu je niat saya. Saya tak nak bagi awak stres. Saya pun tak nak stres. Awak penat kan? Saya pun penat. Awak pun penat. Nota saya dah bagi. Jadi, I already give you the notes. So just refer to the notes. If you not understand anything, just let me know. Don't just keep quiet. I just want to give you knowledge. And I just want to give you a good grade. Saya nak bagi awak grade yang bagus. Kalau awak tak, if you don't want that good grade, so it's better for you to drop this course. Because if you don't want the good grade, it will affect your result. Saya tak marah, tapi saya macam korang tak sayang ke your PNGK, PNGS, your CGPA kan? Tak sayang ke? Saya harap you all boleh dapat 4 flat, 4.0, 3.7 for this course. Kalau you all sendiri yang tak nak, macam mana? Nota saya bagi. Nota ni, the notes that I wrote for you, it's fresh, it's fresh. It's real-time notes. So whatever that come out from my mouth, I write it on the paper, real notes. So each semester, the note is different. It based on the understanding of the students. Saya tak bagi note yang you baca, you tak faham. I never use that kind of notes. Because I don't like that kind of notes. The notes that you just refer to the PowerPoint slide. You just read it without knowing what is the content. So that is why I wrote everything that I say. So your task now is to understand whatever come out from my mouth. Kalau tak banyak pun sikit lah. I know within these 3 hours, not everything that I told you, you will get it. I know. At least you know something. Something. Only that's why I ask you, what's the only one sentence, only one statement. What did you learn in this course since from the first week? Only one sentence. What does it mean? It means that at least you know one thing from all the knowledge, all the things that I give it to you through this course. So I'm not expecting you guys got everything in this class. So for this question, you see here, I already copy paste for you the formula, you see. Actually, you already have your own formula, right? You just by referring your note, you just scroll up and see the formula and look at the formula. But I help you, I scroll up, I copy and I paste it here, down here. This is the way how I'm trying to help you. Tak susah pun. And then you guys, you need to select lah which formula that can be used. Kan dah ajar dah, kan dah ada rules tepi ni. Dalam formula mathematics, in all mathematics formula, there is a rules how to use that formula. You cannot simply use that formula without rules. Same goes to exponent and everything, the polynomial, for the quadratic expression. There is a rules to use that formula. Same goes to this formula. It has rules. So the rules is here. It's stated over there. So my question, the first question is, which So you can't answer that question. Itu pun tak boleh nak answer macam mana. Lepas tu saya tolong lagi. Okay, untuk pilih soalan, to choose which formula, you need to find out the exponent. I help you to find out the answer, but no one answer. You don't know how to get the exponent in these 32 bits. You don't know how to get the exponent, even though I already very clear here. Up here is very, very clear. I put a color on it. See, sine, the dark gray here is exponent, see? Gray, the dark gray, the dark gray, the blue one, the light gray, see? I use the color to differentiate the content of the fraction. You still doesn't get why I use color, you see? This is the exponent. Takkan nak ajar satu-satu. Color, I dah guna color untuk buat macam nota saya belajar, you see? I put color just like what the notes that I used during my student time, you see? The yellow, the dark gray here relates to the dark gray here. The blue here relates